This one's a little bit different. It's balancing a redox reaction in basic solution. So again, we'll start by identifying the oxidation states for everything in here. So here we've got hydrogen peroxide. So the list for the nonmetals was fluorine first, then hydrogen, and then oxygen. So hydrogen gets to be what he wants to be. So hydrogen gets to be +1. Then what is oxygen? Oxygen here is -1. It doesn't happen a lot for oxygen, but it happened here. Here we've got chlorine and oxygen. The list went fluorine, hydrogen, oxygen, group 7. So oxygen gets its choice above chlorine. So oxygen gets to be -2. There are 2 of them. That's a total of -4. Has to add up to 0. Chlorine has to be +4. Then we go over here. This is chlorite ion. And again, oxygen gets his way or her way. Now the total has to add up to -1. So what's the oxidation number for the chlorine? It's going to be +3. Because 3 minus 4 is -1. There's 2 of these. Oops, 2 of these. So 3 minus 2 is -1. And then oxygen over here is what? 0. It's an element. So what's being reduced? Who has an oxidation number that's being reduced? Chlorine, going from 4 to 3. So that's the reduction. And what's being oxidized? We got oxygen. Oxygen's going from -1 to 0. That's oxidation. And this one is also being oxidized. Oh, this is going to be messy. No, I'll just do it this way. So we're going to write our 2 half reactions. Got ClO2 going to ClO, sorry, that's ClO. No, I was right the first time. ClO2 going to ClO2 minus. So I was a little off when I was drawing those arrows, because this is -2 and this is 0, but there's also a couple of oxygens that stay the same, right? So these oxygens that are with the chlorines don't change. It's these oxygens over here. So you've got H2O2 going to O2. So we're going to balance with respect to mass first. This top one is already balanced. There's 1 chlorine and 2 oxygens on each side. I'm going to balance the charge using electrons. I have a -1 charge on this side, so I need to add 1 electron on the other side. Now down here, the oxygens are balanced already, but the hydrogens are not. So we balance hydrogens by adding hydrogen ions. And then we're going to add hydroxide ions to neutralize those, because it says in basic solution. So however many hydrogen ions you have, you're going to add that many hydroxide ions to both sides. So I'm going to add 2 OH minus on that side, and I'm going to add 2 OH minus on that side. When you put hydrogen ions and hydroxide ions together, they form water. So this right here is 2H2O. So I now have it balanced with respect to mass. I need to balance the charge. Over here I've got 2 minuses, so I'm going to add 2 electrons over here. What do we have to do next? Yeah, we have to get the number of electrons to be equal. So I've got 2 electrons over here, and I've only got 1 over there. When I add them together, they're not going to cancel each other out. So I have to multiply this top equation by 2. Now when I go to add these together, these 2 over here and those 2 over there cancel out. So I've got 2OH minus plus H2O2 plus 2ClO2 goes to 2ClO2 minus plus O2 plus 2H2O. I left the state symbols out because there was no way that was going to fit. The order that you write the reactants doesn't matter. The order that you write the products doesn't matter. Because 2 plus 3 is 5, and 3 plus 2 is also 5. Any questions? Yes?
Yeah, we're getting on the oxidation numbers for like the plus 4
Mm-hmm.
and the plus 3. I don't get.
Okay. Let's look at that. So you understand where the minus 2 is coming from for the ClO2. So that has a minus 2. We figure out the charge or the oxidation number for chlorine based on the fact that all the oxidation numbers have to add up to whatever charge that species has. This is neutral, so they have to add up to 0. So there's 1 chlorine, I'm going to call him X, and I've got 2 oxygens. They are each an oxidation number of minus 2, and those have to add up to 0. So I've got 2 times minus 2. This is a minus 4. So in order for this to equal 0, X has to be plus 4. Okay? And for the chlorite ion, it's a similar thing. X plus 2 times minus 2, but this time it has to add up to minus 1. Because this is a polyatomic ion, it has a minus 1 charge. And so then X ends up being plus 3. It's a good question. Any other questions? So this is the overall list of things to do. So if you're trying to balance redox reactions using the half reaction method, there's the steps to go through. This is a really long section. This is kind of an interesting chemistry and the environment section, talking about photosynthesis and respiration. So we know the sun shines, right, and the energy comes to Earth, and that's electromagnetic radiation, and we've learned what that is. It has a wavelength and a frequency. It travels at the speed of light, and it has energy. Plants take in that light, that energy, and use it in a process called photosynthesis to make organic molecules such as carbohydrates. So they can take carbon dioxide from the air and water from the soil and energy that they get from the sunlight, and they can form sugars, C6H12O6, and oxygen. This is an endothermic process. It requires the input of energy. That energy comes from the sun. The key process here is the reduction of carbon. So here we have I'm guessing you don't want to calculate oxidation numbers right now, but here we have 1 carbon for every 2 oxygens, and here we have 1 carbon for every 1 oxygen. So just looking at numbers of oxygens, it's lost oxygen. So carbon is being reduced, and that's photosynthesis. The other part is called respiration. Animals get their energy by either eating plants or by eating animals that ate plants, or possibly eating animals that ate plants, right? But ultimately it all goes back to the plants. It's called respiration. And in respiration, things like sugar are combined with oxygen to form carbon dioxide and water and release energy. So what the plants do is they take the energy from the light and they store it in carbohydrates. And then when other animals eat the plants, they do the opposite reaction, and they take the carbohydrates and they burn them to form energy. So the key process here is the oxidation of carbon. We've gone from a 1-to-1 carbon to oxygen ratio to a 1-to-2. It's gained oxygen. So the opposite process. So if you think about it, redox reactions are at the very center of life. Without redox reactions, we wouldn't be here. And all the energy for life comes from the sun. I think it's neat.